This video will continue our review of the method of partial fractions by considering the second case when the denominator has a repeated linear factor in the denominator. So in this case, I have a rational expression. The denominator is being factored for us. One of the factors is x. That is a linear factor. And then I have the linear factor x minus 2, but it's repeated. It's being squared. In this case, what will happen is, as before, we'll see a term corresponding to the factor of x, so that will be a over x. We'll get another linear factor, a linear term corresponding to the x minus 2. But because it's repeated, we're going to have a third term. That third term will look like a constant, which I'll call c, over x minus 2, but now squared. In order to find what a, b, and c are, we carry out the same techniques as we do in the distinct linear case. First thing that we would want to do is clear the fraction. So I'm going to take both sides and multiply by x times x minus 2 squared. On the left side, that will give me just the numerator again. On the right side, every term will get multiplied by that denominator. Something will cancel, and we'll be left with the remaining factors. In this case, the x will cancel, and we'll be left with the x minus 2 squared. In the third term, one factor of x minus 2 will cancel, and we'll be left with x times x minus 2. And in the third term, both factors of x minus 2 will cancel, but I'll be left with just the original x. I'm now going to take that right-hand side and expand everything out, so I will be able to compare the coefficients later. Here I have a, and I'm foiling out that expression, x minus 2 squared. I have b, and I'm going to expand the x times the x minus 2 to get this. And then we have plus cx. Just rewriting the left side, and then looking at the right side, I'm going to start looking for the degree 2 terms. There's a times x squared plus b times x squared, so we have a plus b of the x squares. We now repeat that for the linear term. It's going to be a times minus 4x, so it will be minus 4a. It will be b times minus 2x, so minus 2b. And then plus cx, so plus c is going to all contribute to the coefficient of x. And then finally, we look for the degree 0 terms, the constant terms, the ones that have no x in them. And I think there's only one here. It's a times 4. That's the only way to get a constant term, and so that will be the constants over on the right side. Now what we do is we compare the degrees, and we look at their coefficients on the left and the right-hand side. I'm going to make a list here. The first thing that we need is the x squared coefficient. On the right side, it's a plus b. I then look at the left side, and I see an x squared coefficient of minus 1. I'm looking right here at the minus x squared, so its coefficient is minus 1. That determines the other side of the equation. Now let's look at the degree 1 coefficient. It's this long expression minus 4a minus 2b plus c. I compare that to the right side, that's plus 3. And now I look at the 4a and compare that to the 4 over here. Those are the constant terms, so degree 0 if you like. 4a is equal to 4. From that equation, we can quickly get that a has to be equal to 1. I can substitute that into the first equation to solve for b, and I get that b is equal to minus 2. And then subbing that into the third equation, or the middle equation rather, I can solve for c, and I can find that c is equal to 3. Then we go up to the top again here, and we put those values in. A is 1, so 1 over x. B is minus 2, so minus 2 over x minus 2. And c is 3, so that third term, the repeated term, gets a 3 in the numerator. This expression here is the partial fractions decomposition of the original rational expression. And we can now integrate it if that was our goal. And instead we can integrate each one of those terms. And each one of those is much simpler than the original expression to integrate. The first one is the log of x, minus 2 times the log of x minus 2, plus 3 over x minus 2 here. Notice it's not a logarithm anymore, it's degree 2 in the denominator. And if you were to differentiate that, you would get a minus 1. So we want to make sure that we've got the right sign here. We'll need a negative here to make everything work out correctly. So in order to check, just differentiate this expression here. You'll get plus 3 over x minus 2. And don't forget your constant of integration. The two logarithmic terms can be combined. The third term is not logarithmic, so it can't be combined with those, and we'll just have to carry that along. And don't forget the constant of integration, and there is the antiderivative for that originally complicated rational expression.